only. So the time of each and every situation, each and every extension of the decision tree, we have to making a lot of questions. Based on that questions, based on its answers, we have to extend the decision tree structure. The idea is to quantify this question of how much information is provided to you by knowing certain facts. Is encoding this mathematically is the talk of information theory. With the help of this information theory, it is very efficient to find how much information is provided to you to knowing certain facts. So for example, the way is we have to use for find the information theory or the value which we have to find, which one is best to find the fact to making a decision tree, is the entropy. The entropy in information theory is an efficient way as we have to find a solution for making a decision tree. The information theory was born in 1948 when Claude Shannon is published a paper, a mathematical theory of communication. In that paper, he proposed the measure of information entropy, which described the amount of impurity in the set of features. So the entropy H of the set probability is going to gather with the help of this particular formula. So the entropy of P is equal to minus summation of Pi log 2 Pi. So this Pi is in some features, so we have to take included in this particular calculations to find the entropy value of the feature. So we can able to find the overall entropy of the whole feature, and we can able to find each and every feature entropy also. That should be an entropy information or in the information value which we have to use to gain the excellent value to construct an decision tree. Is an excellent way, is highly helpful for us to solving a classical problem way, and we have to construct a decision tree also. So where the logarithm is based to, because we are imagining that we encode everything using the binary digits is zeros or ones like, and we define 0 log 0 is equal to 0 also. Suppose that we have a set of positive and negative examples of some feature where the feature can only take two values, which is nothing but positive and negative. However, if the feature separated the examples into 50% positive and 50% negative, then the amount of entropy is at a maximum, and knowing about the feature is very useful to us. The basic concept is that it tells us how much extra information we would get from the knowing the value of that feature. The iterative dichotomister 3. This is an decision tree algorithmic technique which is highly useful for us to construct a decision tree. So the name, it clearly identify what is happening here, like, because this algorithm iteratively is identify repetitions, and dichotomies is identified the divides. This features into an two or more groups at each step of its iterations, which is invented by Rose-Quellen. ID3 uses a top-down greedy approach to build the decision tree. The feature to choose next entropy, we just have to work out how to apply this particular concept here. The important idea is to work out how much the entropy of the whole training set would decrease if we choose each particular feature for the next classification step. Yes, it is most important idea which we are going to use here is to work out how much the entropy of the whole training set would decreases. Based on the above only, we choose each particular feature for the next classification step. This is known as the information gain. This is absolutely is known as the information gain, which we are going to find here, and it is defined as the entropy of the whole set minus the entropy when the particular feature is chosen. This is defined by where the S is the set of examples and F is the possible feature out of the set of all possible ones, and this box SF is the count of the member of S that have the value F for the feature F. Is the particular examples feature is going to identify here. So this particular formulae which we have to frame here, the entropy S comma F, S is the set of all possible examples or set of examples, F is then the features of the particular examples, all possible feature value of that particular example, which is equal to the entropy of S is the entropy of the whole set value minus is an entropy of individual feature values. We have to minus each and every entropy value from entropy of the whole set value. See, for an example, suppose that we have a data with the outcome S is equal to S1 equal to true, S2 equal to false, S3 equal to false, and S4 equal to false. So we have an 4 set of examples S1, S2, S3 and S4, and the one feature F is having different types of values, which is nothing but F1, F2, F3. So in the example above, the feature value of S1 could be F2, the feature of that example S2 feature is F2, and the S3 could be F3, and S4 it could be F1. When we can calculate the entropy for the S, the whole set S, is where plus this means the true of which we have one example, and this minus is false of which we have an 3 examples. We have an 1 true example and we have an 3 negative examples or an false examples. Based on this, we have to find the whole set entropy. So the entropy of S is equal to minus positive log 2 positive minus negative log 2 negative the probabilities. So it is equal to minus 1 by 4 log 2 1 by 4 minus 3 by 4 log 2 3 by 4. So the 1 by 4 it means the total data values is, example is 4, from that 1 is the true value and the 3 is then positive negative values. So based on these calculations, we have to find the value of the first one is 0.5, the next second feature value is 0.311. So by adding we have to get 0.811. So this is the way as we have to find an entropy for an each and every features separately, that is F1 feature, F2 feature and F3 is like. So the entropy for an F1 F1 is equal to 1 by 4 multiplied by minus 0 by 1 log 2 0 by 1 minus 1 by 1 log 2 1 by 1. So the way as we have to find the total value of 0, and the second value is 1 by 2, the third value is 0. So the first feature value is 0, second feature entropy is 1 by 2 and the third one is 0. So the information gained from adds this feature is the entropy of S minus the sum of 3 values. So we have to, this is an whole set entropy value minus this is an each feature entropy value